So hello नमस्कार to the all chemistry lovers and doctors and engineers of the near future. मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू जस्ट केमिस्ट्री. In previous video just we are continue with the just coordination chemistry. Coordination chemistry रिगार्डिंग हमने बहुत सारी बातें कर ली हैं. ऑलमोस्ट 22 वीडियोस में अपलोड कर चुका हूं. Today we'll go with the just different deconfiguration for the octahedral complexes. This is very important. So this is the different deconfiguration for octahedral complex. This is the octahedral complex. Means particular octahedral complex के लिए डिफरेंट डीकॉन्फ़िगरेशंस कैसे होंगे. मींस डिफरेंट डीकॉन्फ़िगरेशंस मीनिंग पर्टिकुलर D1 से लेकर के D10 तक के इलेक्ट्रॉन जब हम फिलिंग करते हैं देन व्हाट विल बी इफेक्ट. सो वी विल टेक जस्ट टू इंपॉर्टेंट डायग्राम. यू कैन सी इफ यू आर रेगुलर विद माय वीडियोस देन यू कैन डू दिस टाइप ऑफ द टॉपिक. अदरवाइज you have to go with the just previous video. As you know that this is the diagram for the just octahedral complex. Here is the T2G set of orbital and here is the AG set of orbital. The energy difference is your del O. This is the del O. If we'll go with the just another diagram, then we'll take this diagram. This is the EG set of orbital. This is the T2G set of orbital. You can see through the diagram. Diagram से आपको इस बात का explanation मिल रहा होगा कि what is the difference. If you are continue with the my video, because of basic part इससे पहले वाली वीडियो में है कि ये वाला जो एनर्जी गैप है ज्यादा है, ये वाला एनर्जी गैप कम है. It means here is the presence of strong ligand. So this is the strong ligand field. If you will go with the other, then this is the weak ligand field because less repulsion regarding to weak ligand field. If you will go with the just D1 to D10 configuration, then first of all we'll go with the D1 configuration regarding to strong ligand and D1 regarding to weak ligand. If you go with the D1, then here will one electron and here will also one electron. So for this we can say T2G is equals to 1 and EG is equals to 0. If we'll go with this, then this is also D1 is also, you can say T2G is equals to 1 and EG is equals to 0. Both exist one unpaired electron, so both will be same paramagnetic. This is the equal sign with the paramagnetic, you can say. This is the paramagnetic. If you will go with the just D2 configuration, so this is the T2G is your 2, so EG is equals to 0. If we'll go with the just another electron for the weak electron, then it will be T2G is equals to 2 and EG is equals to, again it will be 0 and both exist same paramagnetism because both exist two unpaired electron in T2G set of the orbital. Means there is no change for the D1 and D2. If we'll go with the D3, then this is the T2G and this is the EG. If you will go with the third electron, then here will be in T2G set of orbital according to the Thorne's multiplicity rule. So if we'll go with the another for the D3, so here will T2G equals to 3 and EG is equals to 0. If we'll go with for this D3, then this is the T2G again 3, T2G 3 and EG will 0 as a paramagnetic. Both exist same paramagnetism because both exist same 3 unpaired electron in T2G set of the orbital. Now I would like to go with the just D4 configuration. This is the D4 configuration. This is the fourth electron. Here is the strong ligand, so pairing will be in low spin, or you can say just a hyper ligated complex का formation होगा. And if we'll go with the just D4 for this, then energy gap low होने के कारण particular just outer spin या higher spin complex का formation होगा. What will be? Just it will be hypoligated complex for the D4. So this is the T2G is equals to 4 and EG is equals to 0, and this is the D4. T2G is equals to 3 and EG is equals to just 0. Both will be paramagnetic, no doubt. This is the paramagnetic. Both will be paramagnetic. But remember one thing. Here is 4 unpaired electron while here is 2 unpaired electron. So its paramagnetism will be higher than the D4 for the weak ligand field. Now the time to discuss about the D5 electronic configuration. This is the T2G is equals to your 5th electron and EG is equals to again your 0. Due to presence of 1 unpaired electron, it will be just your again paramagnetic. For this 5th electron will be over here, so D5 will be your, you can say T2G 3 and EG is equals to not 0. This is the, sorry, it's a 1, 2, 3 till then D3, and for the D4 it will be EG is equals to 1, and for D5 it will be 1, 2, 3 and 4 and 5. So T2G is equals to 3 and EG is equals to 2. It was mistaken. Both are paramagnetic. What is the major difference? Here is the low spin complex, here is the high spin complex, here is the just 1 unpaired electron, here is the 5 unpaired electron. So its paramagnetism will again higher than the strong ligand field as a D5 electronic configuration. Now the time to discuss about the D6 electronic configuration. This is the D6 electronic configuration. So here will be 6 electron. T2G is equals to 6 and EG is equals to 0. Due to pairing of all electron, it will be diamagnetic. This is the diamagnetic, and if we'll go with this, then here will be 6 electron. So D6, this is the T2G is equals to your, you can say 4, and just EG is equals to your 2. If you go with the just again paramagnetism, then here is the 4 unpaired electron, here is none of unpaired electron, so its paramagnetism will always have. So this is the paramagnetic in nature. But if we'll go with this D6 for the strong ligand, then it will be just your diamagnetic in the nature. This was about the D1 to D6. Now we'll discuss about the D7 to D10. So if we'll go with the just D7 to D10, then what is the major difference between them for the weak and strong ligand? This is the important part regarding to just, you can say, D7. So now the time to discuss about the D7 electronic configuration. This is the D7 for the strong ligand field. This is the D7 for the weak ligand field. Here is the 1, 2, 3, 4, 5, 6, and now 7th electron will be over here. For this it will be 1, 2, 3, 4, 5, 6 and 7. जैसा मेरी fingers आ रही है उसके according आपको fill करना है. For this 1, 2, 3, 4, 5, 6 and 7, 8, 9, 10. For this 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. इस type से आपको fill करना है. So D7, 6 and 1, 7. This is the T2G is equals to your 6 and EG is equals to your 1. If we'll go with this, then T2G is equals to your 5. This is the T2G is equals to your 5 and EG is equals to your 2. If we'll go with the just unpaired electron, then it exists 1, 2, 3 unpaired electron, while it exists only 1 unpaired electron. So its paramagnetism will be higher than the strong ligand field, as I told you in previous. So this is the paramagnetism. So both will be paramagnetic, but its paramagnetism will be higher. If we'll go with the just the D8 electronic configuration, then this is your T2G is equals to 6 and EG is equals to, you can say, 2. And if we'll go with this, then this is the D8 configuration. So T2G is equals to 6 again, and EG is equals to your, you can say, 2. Both will be paramagnetic. But remember one thing, both at the same configuration, so their magnetic character will also same. If we'll go with the just D9, then here will be 9th electron. So T2Z is equals to 6 and EZ is equals to 3. For this D9, so this is the 6 and 7 and 8 and 9. So T2Z is equals to your 6 and EZ is equals to again your 3. The configuration is same. So both will be paramagnetic, but their paramagnetism remains same. So this is the equal sign. For the D10 configuration, this is your T2Z is equals to your 6 and EZ is equals to your 4. EZ is equals to your 4, and if you go with this, then it will also T2Z D10 is equals to just your T2Z 6 and EZ is equals to your 4. Both will be diamagnetic, so that's why I am writing here diamagnetic. Why? Both are exist just paired electron. All the electrons are paired. That's why both configuration will be just diamagnetic. So what we can say that result is your you can say only D0 when there is no electron, then it will be configuration regarding to inert gas. If we are going to take this the element of the 3D series, then that will be equal to the organ. If we are going to just taking the elements of the 4D series, then it will be equal to the krypton, just helium, neon, argon, krypton, xenon, radon. So D0 will always equal to the inert gas. So all inert gas exist paired electrons, so it will be D0. D6 when it will be your strong ligand. We have discussed this is the strong ligand, and D10 either that is strong ligand or that is weak ligand will be as a diamagnetic, and rest all will paramagnetic in nature. Rest all will be paramagnetic in nature. So this was regarding to the different electronic configuration of the just octahedral complexes. Now I would like to go with the just CFT in square planar complexes. It's too important for those students who want to take the extra efforts in coordination chemistry and want to do something in the competition exam with the just 12th also, means 12th के साथ साथ अपना extra efforts लगाना चाहते हैं, ये उन students के लिए है particular, और ये आप लोगों की requirement और demand के base पे ही मैंने extra से extra topics डाले जा रहा हूँ. So this is your, you can say CFT, crystal field splitting theory for just square planar complexes. Square planar complexes. Square planar we have discussed in previous video. Just for the coordination number, this is the coordination number 4. This is the coordination number is your 4. It will be two type of the geometry. One of the tetrahedral, and another is your square planar. This is the square planar. So first of all, we'll go with the just CFT in square planar. If we'll go with the just square planar, then as we know that this is the geometry of the square planar orbitals. This is the square planar. 4 of the orbital lies as follows. This is the orbitals, and these are the axes. If we'll go with these are the axes as a x, y, and z axis. This is the x, y, z axis. This is your z axis. This is your dx square minus y square. If we'll go with the x and y, then we can take x, and this is the y regarding to just geometry. So this is regarding to your square planar. If we'll go with the just diagrammatically, then there are 4. This is the 5 degenerate orbitals. as a square planar geometry. 1, 2, 3, 4 and 5. These are the degenerate orbitals. Degenerate orbitals, and these are the dxy, dyz, dxz, dx square minus y square. Listen me carefully, and this is the dz square. These are the just your 5 degenerate orbitals. If you will go with the splitting, then these splits in 2 parts, as we all know. What are they? These are the T2z and EG set of orbital. As a T2z, here will your T2z here will as a dxy. This is your dyz. This is your dxz, and here will your dx square minus y square and dz square. This is the dx square minus y square, and this is the dz square. Now the energy gap will be denoted by del of sp square planar. But as we know that there are just 5 degenerate orbital in the just square planar geometry. So what will be, if we'll go with the further, then these easy orbital, these easy orbital further splits in 2 parts. You can say like this. This is the number 1 and this is the number 2. So this is the your first of the orbital as a dx square minus y square. I'll explain why it is this possible. And this is the another, you can say, here will be 2 of orbital. Here will be 2 of orbital as a, you can say, dyz, and this is the dxz, and here is your, you can say, this is the dxy, and this is your dz square, dz square. So this was about the splitting of the d orbital. Why? Whenever ligands become the closer, these are the, here is the ligands L, here is the again, you can say ligand, this is the again ligand, this is the again your ligand becomes closer for the bond formation, this is the ligand becomes for the bond formation of the just coordinate bond. So whenever they becomes closer, then as we know that z axis and x square minus y square, these the lobes are not along these axis, so repulsion will be less, then they exist more stability. So due to more stability, it will be high energy of the dx square minus y square and dz square. But if we go with the just the bond formation, then the lobes are along the x and y axis, so it will be more repulsion on the dxy. That's why dxy exists more energy than the dz square orbital. And dyz and dxz, these are just belong between the axis, so they feel less repulsion. So it will be the just splitting of the d orbitals regarding to square planar. And remember one thing, always it will formation of low spin complexes. How? You can say the filling of electron will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the filling of the electron. So read the matter properly and just share the matter. So this was about the important part of the just you can say CFT in square planar complexes. We'll meet in the next video. Till then, namaskar, dhanyavad.